Hello and welcome to World Geography. Today we are going to be learning about latitude, longitude, and GPS. The warm-up questions are, what is GPS? When have you used it? And how does it work? Now these questions, especially what is GPS, I have the same problem with this question as I do with the one that I had on maps where it was, when have you used a map? Because when I asked that maps question, they have a very limited idea of what a map is. They think it's an old school paper map, and they've never used an old school paper map. So they say, "Oh, I've never used one." And when I ask for GPS, all the answers are along the same line. They all say, "Well, it's a program that shows you where you are, and you can use it for directions." And yes, they're right. And when they say maps, that is a paper thing, yeah, they're right. But it's far more than that. So for GPS, and when they say, yes, it's for Google Maps, and I say, yes, that's true. But then I ask them about Snapchat. And I say, hey, does Snapchat use GPS? Some say yes, some say no. I say, okay. So let's say that I go downtown, and we live in Houston. So I go downtown and I take a picture, and I swipe a couple times. What are my options going to be? And they say, well, you're going to have filters that say Houston on it. I'm like, okay, cool. How does it know that I'm in Houston? They're like, oh, GPS. I'm like, yes, GPS. Now, there's two other ways that Snapchat uses GPS. Can anyone think of one? And so sometimes I get stumped. So I'm like, okay, so what if I'm riding a bus and I take a picture on the bus? If I swipe, what are my options going to be? And one of them says miles per hour. And I'm like, yep, that's GPS. Now, there's one more way that Snapchat uses GPS, at least. There's three major ones that I can think of. And that last one would be time. Now, depending on where I'm located physically, my time will change on my phone. So, if I'm in Los Angeles, then my time will be 2 hours earlier than Houston. But when my plane lands in Los Angeles, then it automatically knows and it'll automatically change it for me. I don't have to do that because of GPS. So again, expanding that, I mentioned, Pokemon Go. I mentioned Instagram because they all use Instagram. So I'm like, how does Instagram use GPS? And they're like, oh, well, you can tag location in your photos. And I'm like, yes. So you use GPS all the time. How many of you use Snapchat every day? They all raise their hand. So I tell them, you use GPS every day. If you use Snapchat every day, you use GPS every day. It's not just Google Maps. Does Google Maps use it? Yep. But is that the only thing? No. And a lot of them know that GPS is basically due to a satellite system outside of Earth that works together to pinpoint location. So that's pretty good. Now, I am a teacher. I have 5 periods, which means that every lesson that I do, I have to perform 5 times. And this is a harsh audience. Teenagers are not easy to please. So, in addition to that, I also want to keep myself entertained. So, sometimes I'll make cartoons or I'll make cartoon characters. Even though I know that they're stupid, even though I know that kids are going to groan and be like, oh, miss, really? I don't care, because if they are learning, then that's awesome. Like, that is what should be happening. So I don't care if they are embarrassed for me. That works. So at this point, I asked them about Columbus, Christopher Columbus. I say, okay, in 1492, Columbus sailed the ocean blue, right? Now, why was Christopher Columbus important? And then they all say, he was trying to find a new place. I'm like, okay, I guess that's kind of right. But why was he particularly brave, or how was he particularly brave? and they don't really know what I'm getting at. So I prompt them a little bit further. I say, well, what did they think, let's say 500 years ago, 1492, what did they think the earth was shaped like back then? And all the kids are like, oh, they thought it was flat. And I said, okay, cool. So how many of you think that they thought 500 years ago that the earth was flat? Everyone raises their hand. Okay, cool. So I'm going to tell you, not that people have lied to you, but what I am going to tell you is that they did not know that they were not telling you what actually was the case. So there was this guy. His name was Eratosthenes. About 2000, over 2,000 years ago. I think 2,200 years ago. This was a guy. He was living in Egypt. Eratosthenes. This guy was a genius. He was super, super, super smart. Really smart. Mathematician. He did it all. He according to Carl Sagan, Eratosthenes was like a theater critic and a bunch of different stuff. He was like an everyday handyman kind of thing, but not just with like fixing stuff, but math and science and all this different stuff. So 2,200 years ago, this dude Eratosthenes figured out that the Earth was round, and so because of that, I mean, people in the Middle Ages didn't necessarily think that. And I would bet, considering how many horrible videos you see on YouTube of people being serious about the Earth being flat, I honestly wouldn't be surprised if there are more flat earthers today than there were back in the day. Just because the amazing amount of serious people where you can't even tell if they're trolling you or not, but you kind of think that they're being real. I don't know. But anyway, so again, I make stupid cartoons. So here's a stupid cartoon. See three guys. This is like legit medieval art here. We see three guys on the left, and we see one guy on the right talking to the three guys. So he says, hey guys, what shape do you think Earth is? It's a sphere. Sphere, yep, a sphere. You guys are so dumb, but I still love you, fam. The Earth is flat. If you get close to the edge, you'll fall off, bruh. That's stupid. Not bruh, it's really flat. And in comes time-traveling Eratosthenes from 200 BC. Where the heck did you come from, bruh? Did one of you idiots say that the Earth is flat? It was him. I said he was stupid. Guys, I mathematically proved the Earth was round over 1,500 years ago. Oh, Mr. Super duper smarty pants floaty head uses mathematics. Next, he's going to tell us that it's tilted or something. He's going to tell us how he figured out how many miles it is around the Earth. Sure, I can definitely tell you that. So, you think the world is round then? I'm not sure if I should trust a random floating time traveling head. You suck. Nobody thinks the Earth is flat but you. Yeah, dude. You're the village idiot. Why are we even talking to you? We're voting you off the island. You are the weakest link. Goodbye. You're kidding. Nah, fam. Sorry. See ya, brah. But guys. One more chance. Recall. So, again, people back in the day didn't think that the Earth was flat. Not necessarily. I mean, this dude, Eratosthenes, figured it out 2,200 years ago. And we're still talking about this guy. And this video shows you how exactly this guy, Eratosthenes, figured out how the Earth was round. So I'll link this in the video and in the description. It's by Carl Sagan, about 1970 something, I'm sure. But it's very, very interesting because he was able to pretty precisely calculate how big the Earth was and that it was round. So there was really, I don't think there was a lot of discussion about whether it was flat or not because this guy figured it out a long, long time ago. So I thought that was interesting. Now that being said, we know that the Earth is very big, and we know that it's round. How can we tell someone a very precise location on an area that is so large? What kind of tools, not necessarily tools, what tool do we use? What we use is a grid system, latitude and longitude. Now, latitude goes east to west, left to right, but longitude goes up and down. Don't make it too confusing. Now, the way that I remember it, a latitude is like a ladder. Now, ladder is spelled Ladder, obviously. But latitude, I don't even really pronounce that first T, latitude. I almost say it as a D. So I remember it as latitude is like a ladder. You could even say a latitude. Just don't say latitude outside. Latitude in public because people will laugh at you. Why did you just say latitude? No, I said latitude. But here's the thing. If you're climbing a ladder, you would climb up the flat parts, the side to side pieces of the ladder. So what I do to have them remember is I have them all stand up. And I have them put one fist in the air as though it's hanging onto a ladder. And I say lat, and then I have them put up another fist of their other hand, and then they're climbing up the ladder, tude. So they're making the hand motions as though they are climbing up a ladder, and as they are reaching the next rung of the ladder, they're saying lat, tude, lat, tude, as if they are climbing up a ladder. And I know that they all feel really stupid when they do that. But I guarantee them that when they're taking the test, they will see someone who closes their eyes and then does latitude, and then they figure out which way they need to go. It has happened every single time. I have taught this lesson 3 years. People have done it 3 years. Remember that latitude is like a ladder. And physically do it. Lat-tude. Like you're climbing a ladder. Lat-tude. Then there's longitude. The most important line of this being the prime meridian. Everyone knows the equator. People don't know the prime meridian. So make sure that you remember that part. Now for longitude, I don't have as good or as creative as a physical movement as I do for latitude or latitude. But for longitude, what I do is I have them reach up high with one hand and pretend like they're pulling down a zipper, a really big zipper. Maybe it's for a tent or something. They put their hand up, and then they bring their hand all the way down to the ground as a zipper goes all the way down to the ground, and they start up top, and then they go down to the ground saying longitude, and then we go up again, longitude. And we just do that a few times. Now we added an extra element this year of a Simon Says game, where everyone stood up, everyone put their hands out to the side, they stretched their arms out to side, like an airplane. And I said, okay, which direction is this? And they're like, latitude. And I'm like, awesome. So then I put my arms the other way. I have one arm stretched out above my head and one arm down by my side. I say, okay, what direction is this? They're like, longitude. And I'm like, awesome. Okay, so then we play a game of Simon Says. Simon says latitude, Simon says longitude, latitude, and then I automatically get some people out. Simon says longitude, Simon says latitude, Simon says latitude, Simon says longitude. And then we keep going until people drop out. They love it. And it's just fun. It's just, they're standing up, they're not taking notes, but they are learning and they are practicing. So doing the Simon Says game was really, really fun, and it was really helpful for the kids. So I don't think I had that many kids miss these questions on the test, which is really awesome. Again, longitude is long, it's that zipper. So latitude is you're climbing a ladder, lat-tude, climbing up that ladder of latitude. But for longitude, there's a zipper, it's a big tent. You have your hand on the zipper up top, and then you go longitude. From the top of the zipper to the bottom, longitude. Now the equator. The equator splits the Earth up into two hemispheres. Hemi meaning basically half in this situation, half of a sphere. So you have the north part and the bottom part, the south part. It's like if you cut a knife across the middle of the Earth, you'd have two sections, north and the south. The prime meridian splits it the other way. If you cut a knife right along this section, then you'd have two sections. You'd have the west and you'd have the east. Now this is the hemispheres, so you can see what they look like. Now when we put those two together, when we put the equator together along with the prime meridian, we have 4 quadrants. My kids have gone over quadrants in their math classes, so they understand that idea. Now these ones aren't numbered, not like the math quadrants are, but we have northeast and northwest, both of which are above the equator because they're in the northern hemisphere. We have southwest and we have southeast, both because they are under the equator, south of the equator. And we have northwest and southwest, both west because they are west of the prime meridian. We have northeast and southeast, both east because they are east of the prime meridian. Very simple. Now, we don't need those full letters, those full words. We can just use the letters. So, when you're looking at a map of the world and you have latitude and longitude coordinates, the first step that you need to do is to not even look at the numbers. We are not looking at the numbers at this point in time. What we need to focus on are the letters. Our letters are N and E. So let's do one at a time. N. N means what? North. North of the what? Equator. So N is north of the equator. Therefore, we know that it is only at the top part of the globe. So now we only need to look at the top part of the globe. E. E means what? East. East of the what? The prime meridian. Therefore, we know that we only need to look at the eastern hemisphere. And we only need to look at the north. Therefore, I know that I'm only going to be looking in this area. So now I can use the numbers because I know what area I'm looking for. But just eliminate the rest of this globe. You don't need this. You just need to look here. That'll make it a lot easier. 70S, 60E. What do we not need yet? The numbers. So we have S and E. S means what? South of the what? Equator. So we are only looking south of the equator. Now there's E. East of the what? Prime meridian. So now we know that we're looking south of the equator, looking east of the prime meridian. Therefore, I'm only looking here. Now I'm going to use the numbers. Let's try it again. 53 and 47. Where is this? Well, it was a trick question. We cannot find this location on a map. We need those letters because there are 4 5347s. There's 53N, 47W, 53S, 47W, 53, you get my point. There's 53N and S, and there's 47 east and west. Sorry, north and south. I'm messing myself up. We need those letters. Or we can't find out where a place is. 32N, 60W. What do we not need? We do not need the numbers. N. N is what? North. North of the what? The equator. W is what? West. West of the what? Prime meridian. So we're only looking here. I think you get the point. Look at the letters first when you're looking at a world map, and then use the numbers. So here's some practice. Now these ones, they all have the same letters. They all have north, and they all have west. So at this point, we already know what quadrant of the world we're in. We're in the northwest. And the United States is in the northwest. So we need 33 and 112 west. Let me take out the pin. Let's see. Okay. 33 in. So we have 30, 40, 50. There's no 33. But I do know that 33 is between 30 and 40. And I'm going to guess that 33 is going to be less than half. So maybe like, I guess here. Then I need 112. 110, 120, I'm sorry, 100, 110, 120. There's no 112. So I know that 110 is not between 100 and 110. I know that 112 is between 110 and 120. So maybe it's right here. So now what I need to do is, if this was a piece of paper, I would put my finger right here, and I put my finger right here. Another one. And then I would drag this finger over, and I would drag this finger over, and then we see our answer, Phoenix. Okay, let's try that again. 35 in. 30, 40, halfway. Okay. 78, W. 70, 80, 78, maybe here. Okay. So now I'm going to bring this finger over. I'm going to bring this finger over. And here's my answer. Okay, let's try that one more time. 45, 30, 40, 50, halfway, 45, 122, 110, 120, 122. Then I'm going to drag this finger up here, and I'm going to drag this finger over, and there is our answer. So for my kids, they've done this before, but they haven't really practiced it, at least not in a long time. So then what I do is I have them physically put a finger, when we're doing a worksheet, I'll put you need to put one finger here, your left finger here, and on your right hand you need to put another finger here, and then physically drag them towards each other and see where they meet. And the more you practice this, the easier it gets. There's lots of worksheets online. Practice it. Okay, so that was latitude and longitude. Now we get into GPS. GPS is the global positioning system. It uses satellites to find accurate position, speed, and time information almost anywhere in the world. So again, it's like this web of satellites. This is not a real picture. This is a Photoshop picture. This is a system of satellites surrounding the Earth that allow us to work. They work together to pinpoint locations, pinpoint exact locations. They can pinpoint time, things like that. But what are some limitations of GPS? Think about that. Then there's GIS. GIS, not GPS. GIS is called the Graphic Information System. It connects data to geography using computer-based tools, and there's maps and layers. So what I show my kids is I have 3 transparencies. On one transparency, I drew water. So I drew like a stream and a pond. On another transparency, I put land. And the last transparency, I put roads. Now, I can look on just the water one, or I can look at just the land map, or I can look at just the road map. But to get all of those things together would be a much clearer picture. So then I combine them all, and I see all of the different layers. Okay, so these layers of information create a much clearer picture. But if you're only looking for one bit of information, then you can choose to only use one. But when you're layering them on top of each other, you get a different picture depending on what you're trying to look at. So we see here it starts with customers, streets, parcels, elevation, land usage, and then all together. So depending on what you're looking for, you need to use different maps. You don't need all of these all the time. If you're just looking for customers and which areas you service, then you don't need to know about elevation and you don't need to know the parcels of land. But you may need to know streets and you may need to know customers. So it just depends on your use, what you need to use it for. And then the last part. This is really, really basic stuff. It's in our TEKs to teach about this, and we use them so often, but it feels like I'm just talking to a wall. Basically, we're just going through and I'm just verifying that they know this information as they should. But this is complicated because there's actually two answers here. You could argue that this is a bar graph, absolutely. And the answer that I was looking for was a pyramid, population pyramid specifically. But they have never seen this graph before, I know that for sure. But we look at these a lot. And they're awesome. Some teachers that I know, they hate to teach population pyramids, but I don't know what they're doing. I don't know why they think it's not fun. Because you can tell so much. You can tell if there was a disease that happened. You can tell if there was a war that happened. You can tell if they have a policy that restricts birth, like China back in the day, or what happened and who lives there, and if they need, old folks' homes, or whether they need daycares, or what do they need. So you can tell a lot about population pyramid. And as we get into the year, I'll explain population pyramids further. All right. So that was everything. Please remember latitude and longitude, and latitude is like latitude, which is like a ladder, and you put one fist up and then you put the next fist up as though you're climbing a ladder, and when you're climbing onto these rungs, you say lat-tude, lat-tude, climbing up that ladder. And then for longitude, remember it's like a zipper, a very big zipper, where you're starting all the way up as much as you can stretch, and you're holding that zipper, and you unzip that tent all the way to the floor. And when you're starting at the top, you say longitude all the way down to the floor. Do that a couple times. You could also do Simon Says. Latitude is flat, flatitude, and side to side kind of thing, like you're an airplane or a bird. But then longitude, you have one hand stretched up way above your head, and the other hand is down by your side. That is longitude. Let me know if you have any questions or comments or other ways that I can teach this. And thank you for watching.